Okay, so on this section, it's on functions and the coordinate plane. And we'll try to review some things that you've had before. Some terms and definitions. Okay, functions and the coordinate plane. First thing, the author goes in and defines a relation. Okay, a relation is any set of ordered pairs. Okay, any set of ordered pairs. Now, when they talk about a set, that means you have to have the braces. Okay, and I'm going to make up some ordered pairs. Like if I had the ordered pair 9, -5, the ordered pair 4, 3, and the ordered pair 0, 7. And remember, these ordered pairs are always written X, then Y. Okay? And like I said, if it's a set, you have to have those braces. So any set of ordered pairs makes up a relation. Okay, then another special definition you need is the domain. And the domain is the set of all X values. Okay. Now, they might write it like this. The domain equals, in my relation that I've made up here, the domain would be 9, 4, and 0. It's the set of all X values. Some authors write it like this. The domain equals the set of all X's, and then they might use a colon. And that's just that author's notation. And you read it, the set of all X values such that, okay. Another author might write it like this. And that's like the set of all X values, then, and they read this line such that the set of all X values such that X equals 9, 4, and 0. Okay? So any of those will work. Basically, I just want to show you because the different authors write it differently. Okay, and the other one is the range, and the range is the set of all Y values. Okay, and since they have, like up above, the set, so the range, you're going to have to use a brace. The range is the Y values, so if you look, it's all the Y values up here, and the Y values are -5, 3, and 7. Okay, -5, 3, and 7. Okay. Then the author goes back through graphing on the Cartesian coordinate plane, and that's named after the mathematician René Descartes or Descartes. Okay. Okay, and we've graphed on the Cartesian coordinate plane before. Okay, remember it's separated by two axes. This is the x-axis. This is the y-axis. The point where they intersect, that is the origin. And the origin has the ordered pair 0, 0. Okay. When you look at the Cartesian coordinate plane, it's separated into 4 quadrants. Okay, this first quadrant is quadrant 1, and they will always use Roman numerals. Okay, the upper right hand is quadrant 1. Okay, this is quadrant 2. This one is quadrant 3. And this one is quadrant 4. And 4 is IV. Remember, the V represents 5, the one before it subtracts 1, so IV. So quadrants, those are all 4 quadrants. Okay, and those you have to basically have memorized. Okay. The next thing the author talks about in this section is they will give you a graph and ask you to describe the domain and the range. Okay, so I want to look at some examples. Okay, so the directions will say find the domain and range of each relation. Okay, and just do a sketch. And let's say I have a graph that is a parabola. And it intersects down here at 0, 0. Okay? Now, when it intersects like that, okay, and they're asking you to find the domain and the range. Okay, the domain is what x values are being used. So when you look at that, you go from left to right, okay, and say, am I leaving out any x values as I go left to right? If this extends on up, would you be leaving out any x values? No. Okay, so the domain is, and they're not leaving any x values out, so it's the set of all x's such that x is, and some authors will write it in italics, but I use a double bar R for real numbers. Okay, you could also write that the domain equals all real numbers. You could write it out in words. The domain is all real numbers. Okay. Okay. Then for the range, okay, for the range, you go from the bottom up, okay, and say, okay, what y values are we using in here? So the y values actually start at the origin. Okay. If you're looking, you're going from the bottom up, and the y values actually start here and go up. Okay, so the range is the set of all y values such that y is greater than or equal to 0. Okay, so y is greater than or equal to 0. Okay. 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 Then the next thing the author talks about is the definition of a function. This is by far the most important definition in upper level math. A function is a special relation it's basically a special set of ordered pairs, and I'm not sure how you memorized it in Algebra 1, Algebra 2. If you memorized it a certain definition, that's fine. The way I say it, for every x value, it is paired. You can say paired or mapped with one and only one y value. For every x value, it's paired or mapped with one and only one y value. Okay, and let's look at some examples. Say they give you the directions. Are these relations functions? They might write them as just a set of ordered pairs. They might write them as in a table. They might show it to you on a graph. Okay. Example. Say I give it to you in a table form. Say the first ordered pair is 5, -9. Second one is 6, 8. and then 1, 3. What you have to do is you have to look at each ordered pair and say, okay, 5. 5 is mapped to -9. Is it mapped to one and only one thing? Yes. 6 is mapped to 8. Is 6 mapped to one and only one number? Yes. And 1 is mapped to 3. So yes, this one would be a function. Okay? Another example. Say I give you 5, -9, 5, 8, and 5, 3. Okay, 5 is mapped to -9. Is that the only thing it's mapped to? No, 5 is also mapped to 8. As soon as you find one of those, then it's not a function. Okay. Another example. -9, 5, 8, 5, and 3, 5. -9 is mapped to 5. Is that the only thing -9 is mapped to? Yeah. 8 is mapped to 5. That's the only thing it's mapped to. So this one is yes. So basically, if you're looking at it in table form, you can't repeat in that X column. Okay. What's the test on graphing for whether or not it's a function? The vertical line test. Yep. If you're looking at the picture of the graph, the vertical line test, if any 2 points line up vertically, then it is not a function. So you can tell by sight. Okay. So what's the only type of line that's not a function? Vertical line. All vertical lines are not functions. Horizontal lines would be functions, yes. Okay. Okay, so they also get into a little bit of the function notation for the function. And they can use f of x, g of x, h of x. Usually they'll use f of x. And if they give you a formula, this one's going to be -3x plus 2. And let's say they ask you to find f of -2. All that really means is everywhere you see an x, you're going to substitute in -2. Okay, so you would put in f of -2 would be -3 times a -2 plus 2. Okay, and would be end up to be 8. If they said find f of 5, okay, so you'd put in -3 times 5 plus 2. Remember order of operations. All of this order of operations still is true. So that'd be a -15 plus 2 would be a -13. Okay? And that's an easy one on ACT to tell, you know, have you had any math that involves functions? It's not asking you for a whole lot, it's just asking you to substitute in. Okay? Another thing this author goes through in this section is they will ask you to determine which real numbers must be excluded from the domain. Which real numbers must be excluded from the domain. Okay. Now, when you see this phrase, must be excluded from the domain, you're worried about two things. Okay. You're worried about division by 0. Remember, we cannot divide by 0, so you're worried about what's going to make that denominator 0, and you're worried about the square roots of negative numbers, the imaginaries. Right now we're starting out, we're back with the real number system. Okay. Okay, so if they give you as an example, I'm going to give you about 4 of them. Say I give you f of x equals 7 over x. So what's going to make that denominator 0? 0. So that's the one you exclude. Okay? So x cannot equal 0. Okay? That would be your answer. What values must you exclude? X cannot equal 0. Say I gave you g of x. G of x equals 3x over 2x minus 8. What's going to make that denominator 0? 4, right? So that's what you exclude. Okay, and if you're not sure, what you do is you actually set that equal to 0 and solve, and then that's what you exclude and say x cannot equal 4. Okay, and that'd be your solution. Okay. If I give you an h of x, say h of x is 4 over x squared minus 25. How would you factor that denominator? Difference of two squares? X plus 5, x minus 5. Okay, so, or you could set x squared minus 25 equals 0, add 25. So on this one, x can't be 5, and x can't be negative 5. Okay, you need both exclusions. Okay, and let's say I give you k of x equals the square root of x. What's going to make that? We're not worried about division by 0, we're worried about square roots and negatives. So what's going to make that negative? Less than 0. So x cannot be less than, so you take your less than symbol and not less than 0. Okay? And if you weren't sure, you set that equal to 0 and then solve for x. Okay? Okay? I want to go back and look at a couple of more graphs. Okay. Let's say I had a graph like this, and if I ask you to find the domain and the range, okay? For the domain, you look starting from the left and go to the right. First x value that we use is 1. So, and every x value greater than that. So when you write the domain is the set of all x's such that x is greater than or equal to 1. It is equal to it. Did I have equal to on that other one? Yeah, I did. Okay, just checking. Okay, and the range, if you start from the bottom and go up, and if we extend this graph on down, are they leaving out any y values all the way through? No. So on this one, the range would be a set of all y values such that y is, it's all real numbers, right? Y equals all real numbers. Okay. And there's more than one way. You could just write that the range equals all real numbers. Okay, that would also work. Okay. Last example on the same thing, domain and range. What if I give you a graph like this? Let's say this is 2 and this is up 1. Let's say there's an open circle right there. Okay, now look at the domain. Go left to right, across the graph. What y value am I leaving out? Or excuse me, x value. Sorry, x value. What x value am I leaving out? There's an open circle at x equals 2. So it's every value except x equals 2. So x cannot equal 2. In the range, what y value am I leaving out? 1. So y cannot equal 1. It equals everything else, but not 1. Okay. Okay, that's a little bit on the